whenever they receive a larger sequence number, they should go with that one. So that is a rule in the system. Let me see. So one question. Yes. So basically means if you're working on a blockchain on the branch that eventually it's not the longest, your work is wasted. But that's a cost we need to pay because it's a distributed system. It's not synchronized all the time. Yes, but it's in some sense it's fair, right? Because the reason you are working on some chains that are eventually not useful because you don't have the most updated information. Means that the rest of the work is already on the 6th block, but for some reason you didn't receive it because they broadcast, but you didn't receive it, right? So to some extent, it's your problem. It's not the problem of the rest of the world, right? So if you don't want to have it, then have a better network, right? To make sure that you can receive the information as quick as possible. And then the chance to work on another chain will be much smaller. But on average, this chance is not very large. So don't worry. I just, in this figure, I plot the extreme case, but in real case, it's not, right? Because to work out a block, it takes roughly 10 minutes. Right? But the broadcast in the current network, right? As long as you don't have a network issue, you may receive the broadcast within 1 second. So it's very unlikely that you will create a chain that more than 2. So most of the time, there is a very clear consensus which one should be the longest chain, right? But the mechanism is there, right? So in some cases, really we don't know which one we should go. Right? This is a rule. Right? Which also means if you are B or C, you receive a Bitcoin from A, you should be careful because if only on block 2, both B and C will get the confirmation that the transaction is added to the blockchain. Right? But later, in this case, C's transaction is actually invalidated later. Right? So if C already gave some goods or some product to A before that, then C will be a very bad situation. Right? Therefore, the rule of thumb is that you need to wait after some blocks, right, to make sure that your transaction is actually on the longest chain. Right? So if you wait for 1 hour, right, so basically after 6 blocks, so it's very, very unlikely that the reaction, the transaction is in reverse. Right? Of course, the larger amount it is, the longer you should wait. Right? But the chance that it will be reversed, that go decrease exponentially, right? Very quickly. So that's why, right? So that's all the costs, right? We pay for the decentralized system. Okay, so there are potential attacks to this Bitcoin system, right? So how to decide if we receive the Bitcoin as I just described, right? So you should wait longer if you are not very certain, or if the amount is very large. Second is that because you do majority vote, so if someone controls majority of the mining power, they can do it, right? But for the first one, right, you just wait longer. The second one, in order to control the mining power, right? More than 50%, it's not easy, right? Because if you go online to search, to do that one, you need to spend $1 billion on that one, right? And even you control more than 51%, it's that you can change everything. It's just for the next block, right? You have a good chance that you can be the you can create the next block. But still, there are a chance others realize, right? So you may make the system down, but once the system down, it's not a lot of money you can get from the system, right? On the other side, if you get such a large fraction of the mining power, getting the reward may be a better option. Right? So that is, but remember, as I told you, for any blockchain system, this kind of a 51% attack is always there. Right? So you should always be aware of that. Right? So the attack basically means that the upper limit is upper chain is a real one, but the malicious one they can create a new one, but they have a higher chance to create a longer one. Right. So okay, so let me say. Right. Okay, so I have 5 minutes left. So let me show you this one. This is a Bitcoin white paper, right? The original paper. So I encourage you, especially those who are interested on cryptocurrency, blockchain, or even just for distributed system to read the paper. Even from academic standard, this is a genius design, right? As a distributed system. Of course, from the real impact, right? So it's very rare to see one paper has a such big impact on the real world. Right? It has a potential to completely change the landscape of the financial system. Right? And the distributed system design is a very, very smart design. Right? So let me say if we have you can, and also if you are interested in blockchain technology, but you never read the paper, so that will be awkward, right? So you say in the abstract, they mentioned that they want to get a purely peer-to-peer version. They use a digital signature. They try to prevent double spending. They use a hash-based proof of work as the longest chain. Right? So basically, you can say all the design is in the paper. So after the paper, it's very easily people develop the system, and all the code is open source. Right? You can look into the code, then you can know how to write a blockchain system. Okay, so you can see here, this is the transaction, as we mentioned, you sign the signature. And this is the proof of work, right? How it works. So basically, these are the steps to run the network. Right? First is new transactions are broadcast. If you want to do a new transaction, broadcast to all nodes. And each node will individually and independently collect new transactions into a block. Note here, each node may have a different set of transactions. And next one is that they will work to find the random number. Right? And when a node finds the random number, it will broadcast the block to all nodes. And this one, because it's a distributed system, we may have more than one node find the number roughly at the same time, so that they basically maybe more than one block broadcast at the same time. And the node will accept the block only right? If it's the transaction are valid and not spent yet. And also they accept the longest chain. Right? That is how it works. They also use the Merkle tree, right? For those students who are interested in data structure, right? Let's say this is a concrete example utilizing the Merkle tree to reduce disk space needed, because at that time they still use disk space. And nowadays you say their calculation, right? Only 32 gigabyte. I think the memory we can already hold it. But in the old days, they still consider using the disk, right? But now we have much better situation. They also consider different issues like combining or split value, right? And this is a privacy, how to handle that one. Right? So in the traditional privacy model, is that everything, your identity, transaction, right? All those go to the trusted third party, for example, the bank, and also some other counterparties, right? And then we try to protect those from the public, right? But the third party, they actually have all your information, right? If someone attack a bank system, then they can get all the information. Right? Okay, in the new private system, so the transaction is open to the public, right? It's the identity, you hold your own identity and you protect it, right? Traditionally, it's more like a centralized mechanism for privacy. But the third party, the centralized entity will be the bottleneck and for other to attack. Whereas in new privacy model, you are responsible for your own privacy. And also they calculate the chance, right? They do some math calculation. This is a probability that you can attack the system. Right? So here you can say if the attacker control like 10% of the mining power, if you wait for 10 blocks, the chance that they can reverse is very, very small. Right? Even though they control 30%, but if you wait like 50 blocks, then you can also make it very small. Right? If you want P to be smaller than 0.001, then you can say that wait for, depending on how many they control, if they control, say, 25%, then wait for 15 blocks will be good enough. Right? But if they control close to 50%, then you say this one is much longer. Right? Luckily, nowadays, so far during the past 14 years, right? So the system still works very well, and still there's no 51 attack percent attack on those systems. Okay, so I finished those. So next lecture, if I have some time, I can talk a little bit about the smart contract. And then next Thursday, I will be away, but we have a guest speaker from IoTX. They actually developed the public blockchain for IoT devices and applications. So they will give the tutorial about their system and about how to use it. Okay, so let's apply. And also next Tuesday, we will do the quiz in the lecture, during the lecture. So make sure to attend it. So we won't have an opportunity to make up unless you have an extreme situation such like you are sick and with a doctor knows. Okay, any questions? If not, I will see you next Tuesday.